Good afternoon, class. Okay, at this point we're busy with trigonometry. I think this is our third lesson. We are busy with trig identities, not so? Your homework was exercise 7.2. You had to do the remainder of the exercise, no? Right. Any issues that you guys had with exercise 7.2? On page 288. You have to do number 2, the second column. No? We did all the first. Yes, my girl. Sorry? 2J. 2J. Anything else in number 2? So 2J. So the left hand side. We look here, what is 1 minus cos squared x equal to? Sine squared. So sine squared x plus sine x over, what is common in the denominator? So I'm left with sine x plus 1. So what can happen to the numerator? Take out sine x as a common factor. What are we left with? Sine x plus 1 over cos x into sine x plus 1. So what happens? That cancels. Sine over cos is tan, which is equal to the, okay. Okay. Any problems with number 3? Any problems with number 3? F and G. Okay. Any other problems with number 3? So any problems in the first column? Oh, it's all one column. So it's F and G, okay. Okay, so let's look at F. Okay. So the left hand side we're going to work with. If we're looking at the left hand side, what can be done in the numerator? What can be done in the numerator? The 1 can be written as sine squared x plus cos squared x. Not so. That's your number 1. This 2 sine theta cos theta with sine x cos x, I put in the middle. Why do you think I'm putting it in the middle? To create a trinomial. Can you see that? Don't see the trinomial. What if sine was x and cos was a y? You see a trinomial now? Still not? You do? Okay. So if you factorize this, this should simply be x plus y, or x plus y squared. Not so? The perfect square trinomial. So if you look at this in mind now, when I get into account, that would simply be, if x is sine, it will be sine x plus y, which is cos x. And it must be all squared over sine x plus cos x. So what happens now? Sorry? That sine x plus cos x cancel with one of them. Not so? Gives you a sine x plus cos x over 1, which is sine x cos x, which is equal to the right hand side. Okay. Looking at G. G. Many things I can do. Many things. But what I'm going to do is I'm going to multiply this left hand side by sine over sine. Remember, if you multiply something by number 1, I don't change the value of anything. Not so. So the number 1 I choose here is going to be sine of b over b. We'll see now what. If I multiply this, the numerators will remain sine b into 1 minus cos b over sine b times sine b is going to be sine squared. Now if I'm going to cancel sine b with one of them in the denominator, I'm going to land up with what we are given initially. Not so. So we don't cancel. And many would cancel here and say, okay, I don't know what to do. However, sine squared b can be written as what? 1 minus cos b. That is 1 minus cos squared b. Looking in the denominator, looking at the denominator, difference. Can you see the difference of two squares that can be applied? So that's simply going to be sine b into 1 minus cos b over 1 plus cos b into 1 minus cos b. Not so? Now what? What can cancel? 1 minus cos b cancel 1 minus. So what are we left with? Sine b over 1 plus cos b, which is the same as the like this. Easy does it, no? There is no problem. Okay, any confusion here? There's another way I could have done it. No? Must I do it? Or do you guys understand? Okay. Not now. Okay, now let's look at the next one. Let's see, maybe this one is more of your liking. Okay. Again, I'm going to multiply it with number 1. However, the number 1 I do in this case is actually the conjugate pair of the numerator. Okay? So you should see here 1 minus x times 1 plus x. What would this simplify into? 1 minus x squared. Not so, the difference of two squares there. Not so? Now the same rule can apply here. You see that's being multiplied. I multiply the first and the last. So 1 times 1 is minus cos b times cos b, cos squared b over sine b into 1 plus cos b. But what can 1 minus cos squared b be written as? What can this be written as? Sine squared b. So sine squared b over sine b into 1 plus cos b. So what happens now? Sines cancel. So it's going to be sine b over 1 plus cos b, which is equal to the, which side is better? The same. You're saying the same, or is this one better?
This one better.
Right, sorted? Nice. So that basically brings us to to the end of 7.2. Okay. Next heading, reduction formula. Formulae. Yes? Sorry? Would this be? Tomorrow? Do you think it's fair? Oh, making sure. Right, the reduction formula. Oh, you just want to talk to me a little. See, I feel the same. Reduction formulae. Under that heading, I want you guys to write the following. Reduction formula or formulae are used to reduce a ratio of any angle to a ratio of an acute angle. Okay. So reduction is basically to reduce. Okay. Yes? Yeah. It's basically grade 10 trig. And don't forget, I've sent to the group a folder with the videos explaining chapter 15. That's part of grade 10 trig. As I'm not sure if you guys are well aware that we're actually taking it a bit slower this year. No? We're actually behind. Did I tell you already? No? Okay, it's because of the recording we're doing. Okay. So next year we're going to pick up the pace. Also, I've given you guys the one topic to do the study on your own of. No? You did one lesson of something. Stats. Oh. Yes. At this point you add the second lesson to stats. Okay? I think there's 4 lessons to it. No? You're on the second lesson. For those of you who are confused, we can speak about this at the end of the lesson. Let's just get through this quickly, okay? Yes? Sorry? You're on the second one now. You must be doing the second one now. Okay, so I'll give you about a week and a half, and we'll discuss what the issues are. And then we'll move on to the last two. Because we are moving slow, we are running out of time. And I don't want to carry any topic over to next year. I don't think that's fair. So you're going to be already in a panic. So I don't want you to... okay. Pleasure. Alright, listen. We are looking at reduction formula, and this is on page 229. Page 229. Reduction formula. So here we told the reduction formula are used to reduce a ratio of any angle to a ratio of an acute angle. So looking in figure 1. In figure 1. You don't have to write this down. Okay, this is on page 229 if you want to. Later on as part of your homework you can rewrite this. Okay, you that kind of girl who likes to write. Okay. Go free. Look here. So we are told in figure 1. In figure 1. P dash. You see that dash thing? It's the first image of P. Later on, okay, they still use P dash. But normally they use P dash as the first image of P or the first reflection of P. P double dash as the second reflection, P triple dash and so on. Okay, I see they use P dash here throughout. But okay, it's fine. We are told that P dash, which is minus X and Y, is a reflection of P, which is X and Y, which is this point here in the y-axis. You see we reflect this in the y-axis. Then this point lies here. Can you see that, people? Okay. They want to know in the y-axis, OP has to be equal to OP dash. Not so, both is your radius. Okay. And XOP is 180 minus XOP is 180 minus theta. As you can see, this angle is theta. This angle has to be theta, and then of course angles are the straight line. Let me give you 180 minus theta. Are you all okay with that? Oh my word. Sorry man, this board needs to be aligned again. I don't have time now. Okay. Let's use the mouse. Okay, so the question is, what is sine of 180 minus theta? But just to remember that sine, cos, tan means nothing without the angle. Not so. Sine is Oliver has a hat of apples. Now you some remember Sokatawa and all of those stuff. We're not Chinese, so talk about Oliver and so on. Okay. So sine is opposite. If this is your x and your y, there's your x and y. So it's going to be y over r, x over r, y over x. Okay. That is your normal basic trig ratios. So if you now say, okay, you got sine of 180 minus theta. So I conclude the triangle going that way. Is your 90 degrees. Of course that comes up over a bit. Okay. There's your minus x, that's your y now. You all agree with that? So what does sine stand for? Opposite over. So it's going to be y over r. Cos of 180 minus theta. That's your reference angle here now. It's going to be minus x over r. Tan is opposite over adjacent, which is y over minus x. But if you, what is y over r? Y over r is sine theta. Can you see that? What is x over r? Cos. So that is going to be minus cos theta. Can you see that, people? The next one would be negative y over x, which is negative tan. That again confirms that only sine is positive in the first quadrant, in the second quadrant. You all agree with that? So let's look at the next one. In figure 2. Moving too fast. So I can move a bit faster, you say?
No.
Oh my word. Sorry? Right, here we go, number 2. Right, so with that in mind, again we're going to conclude the triangle. We always drop it onto the x. It means it's a line this board. They're actually wasting more time by not playing games with ourselves, no? Right, let's try now. How's it? So, what would this length here be? Negative y. This here? Negative x. Okay. So now, again, that's my reference angle here. Okay. So we are told in figure 2, p dash, which is negative y, negative x, is an image of p, which is x and y, after a rotation of 180 degrees about the origin. OP is equal to OP dash, which is equal to r. Then we are told that XOP, which is that angle there, is equal to 180 plus x. This means 180 here, plus an angle of theta there. No? They want to know what is sine of 180 plus theta. So in this quadrant, sine, what does sine stand for? Opposite over hypotenuse. So it's going to be negative y over r. Cos is adjacent over hypotenuse, which is negative x over r. Tan is opposite over adjacent, which is negative y over negative x, which is also equal to y over x. Not so. But we say, okay, y over r is what? Sine, according to that thing. So you've got negative sine theta. 180 plus cos. In the third quadrant, it's negative cos theta. Can you see that, people? And then tan, 180 plus, it's just going to be tan of theta. So what does that also confirm now? That was all stations. Only sine was positive early on. Here, what do you notice? Only tan is positive. Can you see that, people? And the last one, same story. Okay? In figure 3, p dash, which is x and negative y, is a reflection of. Now this is actually right, because earlier on I said it's going to be p triple dash and all that. No? That's not right. If you say p dash, then it's a reflection of p. P double dash, if I say p double dash, then that is the reflection of p dash. You understand? And if you reflect this point again, it will be p triple dash and so on. Coming back to this here, in the figure 3, p dash, which is x and minus y, is a reflection of p, which is x and y in the x-axis. OP is equal to OP dash and p is equal to r. Then we are told that XOP, which is this angle here, is going to be equal to theta. The question says, okay, so if you conclude this here, there's your 90 degrees. What is this length here? Which what in terms of x and y? Negative y here. So what does sine stand for? Sine is opposite, which is negative y over r. Cos is adjacent of hypotenuse, so it's going to be x over r. Tan is opposite over adjacent. Can you see that, people? So what do you notice now? So we got here y over r is sine, so it's negative sine theta. This one here, cos theta. The next one, negative tan theta. Okay, which also confirms all was positive there, sine was positive, tan was positive, and cos was positive. Okay. Now I want you guys to, this is basically the summary that follows. Is that if we have the following, all is positive here, not so. So we got sine. Remember this is 180 degrees. If I say minus theta, go in that quadrant. Not so. If I say plus theta, go in this quadrant. That will be 360 plus the angle will give you in that quadrant. 360 minus the angle gives you in that quadrant. Can you see that, people? You all know that's 180 and this is 360, no? You don't have a problem with that. So sine of 180 plus minus theta. Sine cos. So it's sine 180 minus theta, cos 180 minus theta, tan of 180 minus theta. So what is sine 180 minus theta? Remember, this is all stations to clear 1. 180 minus theta in this quadrant is sine positive or negative? Positive. So it's positive sine theta. Cos 180 minus theta is in the second quadrant. Is cos positive or negative? Negative cos theta. 180 minus which quadrant? Second quadrant. Is tan positive or negative? Negative tan theta. Alright, you guys understand? Alright. Now you guys do the next two for me. There's going to be sine 180 plus theta. You write that answer in. Cos 180 plus theta. Tan 180 plus theta. Quickly, no? So this will be sine 360 minus theta. Cos 360 minus theta. And tan 360 minus theta. How do you think? Right, well, sounds like you guys are finished? Yes, right? 180 plus theta, third quadrant, sine positive or negative? Negative sine theta. The next one? 180 plus? Negative cos theta. And the last one? Positive tan, or just tan theta. You all agree with that? Look at the next one. 360 minus, fourth quadrant. Negative sine theta. The next one, 360 minus? Positive cos theta. And the last one? Negative tan. Is there anybody that's confused? No. You all know that this quadrant 1, 2, 3 and 4, no? Yes. Right. Now with that in mind, we're going to answer the following questions. Okay. The examples on page 230. Okay, so let's write down the first one. The question says simplify the following expressions. Number 1, you got sine of theta, sine of 180 plus theta, and that's over sine of 180 minus theta. Okay, you do that quickly in your book. Okay. Okay, so what we do is, you say, okay, we are busy with the cost diagram. So what we do on the side is all stations to Claremont. I write 180 minus plus 360 plus 360 minus. Okay. Always write that on the side as my guide. Okay. So 180 plus theta is in which quadrant? 180 plus theta. There's 2 at the bottom. You can't say at the bottom. Third. Alright. Is sign positive or negative in the third quadrant? Negative. So what do I write? Negative sine theta over. Now we go. That is going to be sine 180 minus theta. Which quadrant is that in? Second quadrant. Is sign positive or negative in the second quadrant? Positive. There's positive sign. So what happens now? What's negative divided by positive? Negative. And what happens? Signs cancel. Leaves you with? Easy, no? Yes. Then number 2. Look at number 2. Looking at number 2, people. What does that square mean? So it's going to be 10, 180 minus theta times 10, 180 minus theta, alpha in this case. Not so. So 10, 180 minus alpha is in which quadrant? 180 minus alpha. Second quadrant. Is 10 positive or negative? Negative. It's negative. So what do I write here? Negative 10 alpha times 180 minus alpha. Which quadrant is that in? Second quadrant. Is 10 positive or negative? Negative. So it's negative 10 alpha. So what's negative times negative? Positive. 10 alpha times 10 alpha? 10? Or just 10 squared alpha? You guys understand? So now if you're looking at this here, we're not always going to write it out twice. Not so? We just tell ourselves, okay, tan 180 minus alpha is in which quadrant? Second quadrant. Is that positive or negative? Negative. But because of the square, it will remain positive. So if you want to, we're going to say it's negative tan alpha squared, which is tan squared alpha. Or you could have gone from this straight into that, you would still get the full mark for it. You guys understand? Any confusion? You all understand, eh? Until you get the test, okay? You write the exam tomorrow, what do you want to test? Let's see, there you got tomorrow a test. Prove yourselves now, no?
Yes, sir.
And now you guys can do it. Positive, there we go. Right. People, let's look at number 3. Settle down. Let's look at number 3. In number 3, we got cos of 360 minus alpha times tan of alpha. 360 minus alpha. So 360 minus alpha is in which quadrant? 360 minus third. Fourth, yes. Fourth quadrant. Okay? So 360 minus alpha is cos positive or negative in the fourth quadrant?
Positive.
Positive. So you write here cos alpha times tan alpha, no? But what can happen there? Nothing. So we will change tan sin alpha over cos alpha. You see that, people? Sin alpha over cos alpha, that's over 1. So what can happen? Cancels, leaves you with sin. Yes. So you know that cos alpha times tan alpha is sin alpha. It's fine. Sine, or sin. Yeah, but then you must know the rule, it's fine. Okay, so what I want you guys to do is exercise 7.3. You do this first column for me here. You see that first column?
Yes, sir.
You do that for me quickly, no?
Yes, sir.
Okay, stop making so much noise, and the girls is laughing at the back. Stop it. Guys, finish. You're done with number 1. Oh, 1A. Pause the video at this point. Alright, so let's look at the sums that I gave you to do quickly. So what's the first thing we do? We draw the cost diagram. all stations to Clement diagram. Remember, this is 180 minus 180 plus 360 plus 360 minus. Okay. So what do we say? 180 minus so 180 minus alpha, theta is in which quadrant? 180 minus theta, second quadrant. So it's going to be negative tan theta. The next one, cos 180 plus theta, negative cos theta. The next one, sine of 180 plus theta, third quadrant, sine positive, negative, negative. You all okay with that? Okay, so what I'm going to do is, I'm going to move this over a bit. For number 2. Number 2a. You got cos of 180 minus theta, beta, over cos of 360 minus beta. 180 minus beta is in which quadrant? 180 minus beta, second quadrant. Cos positive, negative? Negative cos beta over 360 minus beta, which quadrant? Fourth quadrant. Cos positive, negative? So it's going to be cos beta, which is negative 1. You all okay with that? Let's look at C. You got cos 360 minus alpha plus cos 180 minus alpha. 360 minus alpha is in which quadrant? 4. It's cos positive, negative? Positive. Cos alpha. 180 minus alpha. Second. Cos positive, negative? Now that negative times this positive is negative. So cos alpha minus cos alpha, 0. Let's look at E. Sine squared 360 minus alpha. Which quadrant is that in? Fourth quadrant. Sine positive and negative? Negative. But because of the square it will remain positive. So it's positive sine squared alpha. Let's look at G. Cos squared 180 minus theta. 180 minus theta, which quadrant is that? Second. Cos positive and negative? Negative. Because of the square it remains positive. Positive cos squared alpha theta. You guys get the idea? Do I have to do the last one? Yes. I 6 tan 180 plus beta plus 2 tan 180 minus beta. 180 plus beta is in which quadrant? 3. Is tan positive or negative? Positive. So 6 tan beta. 180 minus which quadrant? Second. Tan positive or negative? That negative times this positive is negative. So what is 6 tan beta minus 2 tan beta? Okay. For homework, I would like you guys to complete this exercise. Enjoy the rest of your day, people. Good morning, class. Good afternoon. Yes, Michael. Yes?
All means that everything.
All positive, yeah. So sine, cos and tan in the first quadrant is positive. Yeah.